In this video, we'll be discussing how to read and interpret graphs, which is an important skill not just as a water treatment operator, but also in daily life so that you can understand what you are shown, for example, in the news. Before we get to graphs, we're going to talk about why it is important to be able to use graphs to understand measurements and data. We'll start by looking at a table. If you have a very few number of measurements, a table can be a great way to look at your data. Here is an example of a table where measurements were taken at a particular site, in this case, a drinking water reservoir, and the site ID is given by the code FCRE. The date time of the measurement is also recorded, and you can see that measurements are taken about once a month throughout 2023. The depth of the measurement in meters is also recorded, and in this case, every measurement was taken at a depth of 1 meter in the reservoir. The variable is also recorded. Here we are collecting measurements of water temperature, and then we have the observation. You can see from looking at these few data points that in general, water temperature increases throughout the year until we get to August, and then it starts to decrease, which makes sense. Now, tables are a great way to visualize data if you don't have very many measurements. But let's imagine that instead of just taking measurements at one depth once a month in this reservoir, we took measurements across many depths every day. You can see how this would very quickly be overwhelming for a human to look at and understand. This is where graphs become really useful. So now we'll take a look at the different parts of a graph and how to read and interpret them. Here is a graph that has no data shown on it yet. First, let's discuss the parts of this graph. Importantly, most graphs have two axes. First, the x-axis, which is along the bottom of the graph, usually, and second, the y-axis, which is usually shown on the left of the graph. Axes have labels, which indicates the values that are shown along the axis. In this case, you can see that the x-axis is showing dates from January of 2000 till January of 2001. And the y-axis is showing numbers, 4, 6, 8, 10, 12. It's a little less clear what these numbers represent, but we can get a clue if we look at the axis title, which tells us that in this case, the numbers represent water temperature in degrees Celsius. Another really important of this particular graph is the legend, which is often shown on the right-hand side of the graph or sometimes within the graphing area. In this case, the legend is showing that different colors of measurements will correspond to different depths at which the measurements were taken, and that these depths are measured in feet, which is a little different from the table we looked at earlier, where the depth was measured in meters. Okay, so even without having any data on this graph at all, we already know some important information, which is that we're going to be looking at measurements of water temperature taken at different depths over time. Let's take a look at one of these water temperature lines. Okay, so now we see water temperature data from a depth of 16.4 feet in the reservoir from January of 2023 all the way through to it looks about the end of 2023. How do we read and interpret these data? Let's do that with a couple of practice questions. First, when do you observe the warmest water temperatures at this depth? If you are looking at the peak of this line, you are correct. That's the time when the warmest water temperatures are observed. A handy feature of this particular graph is that these little pop-ups occur when I hover my cursor over the data. So I can get a really precise idea of what the water temperature is and when it occurs. From my pop-up, I can see that the warmest water temperature occurs on October 17th, 2023, and that the value is 14.7 degrees Celsius. How about the coldest water temperature? When does that occur? If your eye was drawn to this low point in January, you would be correct. By hovering, we can find out that the lowest water temperature observed is on January 16th, 2023, and the value of that observation is 3.3 degrees Celsius. How about if we compare these water temperature observations with observations taken at different depths? We can do that by visualizing the data collected at different depths in the reservoir. You can see that this graph became a lot more complicated looking very quickly, but just focus on what is shown in the legend, and that will really help us interpret what's going on. Remember that each of the different colors of the lines is showing you water temperatures that are collected at a different depth. So at what depth are the warmest water temperatures observed? If your eye was drawn to this bright yellow line, you would be right. That's a depth of 0.3 feet in the reservoir, which makes sense. Water temperatures are warmest at the very shallowest depth that we measure. Conversely, water temperatures are coldest at the very deepest depth that we measure, and that's why the blue line, the dark blue line, is shown on the bottom. When are water temperatures about the same from the top to the bottom of the reservoir? When during the year does this occur? Well, we can see that by looking at times when all of the lines are very close together in their values. So you might notice that in January, all of the lines occur very closely together, and all the water temperatures across all the depths are about the same. This also happens late in the fall. When are water temperatures across depth most different? Well, that occurs in the summer. The sun heats up the very warmest surface layers of the reservoir, while the cool bottom waters stay cool. I hope this exercise was helpful in thinking about how to read and interpret data on graphs. Thanks so much for your attention. Have a great day.